Hi everyone, welcome back to my channel. Let's talk about something exciting, project ideas that are going to take your GIS and mapping skills to the next level. Today I'm sharing 5 innovative project ideas that you can explore using R. These aren't just about making maps, they're also about solving real-world problems, exploring complex data sets, and telling powerful visual stories through geospatial analysis. From bivariate climate mapping to 3D interactive plots, urban insights, and even air pollution maps, these projects are designed to spark your creativity and help you stand out. Whether you're a student, a researcher, or just a GIS enthusiast, there is something here for you to explore in 2025. So stick around and let's brainstorm some of the project ideas that I have for you. Project idea number 1 is combining climate variables into 2D and 3D plots. Climate data can sometimes be overwhelming, right? We often look at variables like temperature or precipitation in isolation, but combining them into a bivariate map can reveal relationships we'd otherwise miss. And if you really want to make an impact, why not add a 3D element? Think about this, a map that not only shows how heat and rainfall interact, but also highlights regions at risk in a way that jumps off the screen, perfect for agriculture, disaster management, or even just impressing your audience. With a project like this, you could, for example, explore how temperature and rainfall overlap in certain regions, or what are the trends that come out when mapping these climate variables together. And this is how you could do it in R. First of all, grab global climate data from the World Clim datasets. Then, use the Terra package to process and stack your datasets. Then design a color scheme that shows both variables clearly. For example, try Color Space Library. And after that, you can create your 2D map with ggplot2 or tmap, or you can also elevate it with Ray Shader for that 3D wow factor. Project number 2 is creating 3D interactive maps with mapgl library. Static maps are cool, but what about 3D interactive maps? Well, they're next level. And with the mapgl package, you can bring your data to life in 3D. Imagine letting users explore city skylines, rugged terrain, or population density, all in a dynamic, interactive environment. Several things come to my mind that you could explore. For example, how do urban skylines differ across region? How does terrain affect transportation routes or settlement patterns? Okay, so this is how I would do it in R. First of all, I would install the mapgl package and then prepare my data using Terra or SF packages. Then I would set up a base map with terrain or satellite imagery, and then I would start adding custom 3D layers like buildings, elevation, or data points, and then customize even further this interactivity by enabling zoom, rotation, and even tooltips. And then finally, I would save this as an interactive HTML file that I can share with anyone. Project number 3 is exploring urban densities and accessibility. Cities are hubs of activity, but are they equitable? By using global human settlement layer data coupled with the dodgr package in R, you can dig into different questions. For example, like where are underserved neighborhoods? How accessible are schools, hospitals, or transit hubs? You could even further explore which areas of the city lack access to essential services, or how does population density correlate with accessibility. So this is how you could leverage the power of R and start working on this project. First of all, you can download urban density data from the GHSL and then crop it to your city using Terra. Then you can use OpenStreetMap data to build a road network, analyze travel times or distances to key locations with dodgr package, and then finally visualize your findings using ggplot2 or tmap to highlight accessibility gaps. Project number 4 is uncovering hidden terrain details with relative elevation models. Floodplains, valleys, and ancient landscapes often hide in plain sight, but with a relative elevation model, you can reveal these subtle features in a way that traditional maps just can't. These are especially valuable for flood risk analysis, ecology, and even uncovering historical geography. There's several interesting topics that you could explore with this project. For example, how do floodplains impact local ecosystems? Or what can terrain features tell us about historical changes or natural disasters? And here are my 5 cents on how you can kick off this project in R. First of all, you can download high-resolution digital elevation models from OpenTopography. Then you can process the data with Terra and calculate the relative elevation. And using Glaciator, you can visualize your findings in 3D. Additionally, you can also analyze features like river channels or flood-prone areas for actionable insights. Project number 5 is visualizing air quality patterns. Air pollution is impacting millions of people daily, but it's hard to understand it well without proper visuals. Mapping air quality can help highlight hotspots, track trends, and even advocate for change. With free data from OpenAQ, the possibilities are endless. With this project, you can explore several things. First of all, where are the most polluted areas? Second, what is causing them? And third, how does air quality vary by time of day, week, or even season? And this is how you could do this project in R. First of all, use the OpenAQ API to fetch pollutant data. Then clean and organize the data using tidyverse. And then finally, create static maps with ggplot2 or animated time-lapse maps with ggAnimate. These ideas are just the beginning. Whether you're into climate research, environmental health, urban planning, or something else, GIS and mapping can really help you achieve impact. Which of these projects speak to you the most? Let me know in the comment section below, and feel free to share this with your friends and family. Let's kick off 2025 with some fresh mapping projects.